Hello everyone, and thank you for joining me today. We're going to be talking about SIEM solutions for small security teams, really advice for small security teams looking to make smart decisions in a crowded market. Just to introduce myself, my name is Oliver Rochford. I'm a former Gartner Research Director, so I used to work as an industry analyst. I used to cover security operations, including SIEM, and I was one of the 3 analysts who were allowed to referee on the SOAR name I say, because people say you named it, but you didn't really. There's all of these different vendors and all of these different players really making suggestions, and what you get to do is solve the tiebreaker. I've worked for a number of different vendors, including SIEM vendors like Securonix. I've worked, in a couple of SOCs, and I also did SIEM architecture and consulting at HP while they had ArcSight. At the moment, I'm working with a number of different vendors as an independent, really analyst, including Hunters. And I also do some research by the side and a lot of publications. So I have a newsletter called The Curious AI as well, for example. So if you do want to check me out, there's my LinkedIn profile, and you can also just click the QR code. So let's just dive right in, right? But why SIEM? And I always think it's interesting to note that actually our industry has got quite a rich history. I know people don't realize this. We always talk about tech companies and so on, but actually our security discipline was essentially founded by an astronomer called Clifford Stoll at Berkeley, and Clifford Stoll wasn't able to get an actual job at the university as an astronomer, so instead they put him into the computer department, and at some point he came across a 75-cent accounting error in the telephone bill, followed it up, and actually it led him to uncover a ring of German hackers who were spying and hacking essentially US defense contractors for the KGB. If you do want to dive down a rabbit hole, Google Karl Koch hacker. But the reason why I bring it up is because Clifford Stoll actually laid down in many ways a lot of the theoretical groundwork that we still use today to try to detect threats and hackers. And so in a very real sense, he's the grandfather of SIEM. It's just that, of course, we've gone through a number of different iterations to get to where we are today. But if we look at what a modern SIEM actually is, breaking it down, a modern SIEM ingests data from a variety of different sources. Nowadays, it's streaming logs, APIs, also cloud data stores and data lakes. It does this for a very simple reason, to try to identify and detect threats. But I think what's worth noting is that a SIEM isn't really a primary generator of detections. It's not like an intrusion detection system. A SIEM is a manager of detections, and it also creates essentially meta detections, because an intrusion detection system sees something local to it. It will see something, very specific things. A SIEM is able to put together data from different types of technologies, intrusion detection systems, endpoint systems, DNS logs, and so on. And the whole idea is to be able to uncover threats where atomic indicators might not necessarily indicate something strongly, but if you put them together, that was the whole idea around correlation, it actually does identify something nefarious going on. Of course, that didn't work out for a number of different reasons, the way that people wanted. We'll get into that a little bit later as well. But it's important to note for now that that's the difference between a SIEM and an intrusion detection system. It manages detections and logs from third-party systems. Today, we use a number of different technologies to help with the essentially threat detection and threat investigation, including real-time correlation, user entity behavior analysis, and various machine learning and AI capabilities. Context enrichment, including threat intelligence, user and asset context, because that's really decisive what matters. To give you the best example, a PowerShell command, it doesn't just matter which user ID is doing it, but what it's being done with it and which asset it is connecting to, sometimes even the time of day. And so all of these things have started becoming far more important to detect essentially attackers who have also trying to actively evade our monitoring, right? We also have far stronger capabilities around threat visualizations. Graphs, I think, are the flavor of the month, and is something which I know hunters do very well. Incident management capabilities are also integrated, and of course, increasingly security automation, including endpoint detection and response, integrated SOAR, and going forward, AI SecOps. KPIs and reporting have always been a really big part of SIEM, and I think that's one of the reasons why it's so hard to replace a SIEM with a vanilla data lake, because you still have to do all of that work. It means that the buyer is still going to have to buy something else. They might end up still needing to get an integrated risk management solution, or God forbid, do these kind of reports using Excel spreadsheets or something else. What's also noticeable is that there's an increasing adoption of standards. Now, we don't have a single standard. I love OTSF as an example, and it solves many problems, but it doesn't solve all of them. And the reality is that we have now a smaller handful of competing standards, but that's still better, right? We're better off being able to standardize on 4 to 5 different standards than basically 24 or 50. So these things are all good. And the other thing which we're starting to see is a merging of SIM with data technology, simply because the analytical and AI workloads are starting to push security in that direction. I think it's important to note that there have actually been multiple different SIM generations. And if you go back, ArcSight was built on basically on a SQL database. And next generation came along and basically did big data. Then we had NoSQL, Splunk that kind of mastered that ride. Cloud, scaling it up, and ultimately led to really large scale data lakes. What's interesting about these is that each one of these basically data technology generations had a couple of SIM vendors who dominated, because in a very real sense in the past, a SIM has been a type of database with custom content built on the top, designed to deal with security data. It's been hard to take that custom content and just move it to a new data technology. Interestingly enough, where we are now, that's changed. I think Hunters is a very good example of that, where it's not just dependent on a hard built integrated database, it's built on top of a data lake. And indeed, I think the whole market is going in that direction of decoupling the data layer from the analytical and automation layer. And looking forward, we're going to see an increase in AI. Of course, we've already had that, I think, in many waves within security, but we're all riding this really big one right now, leading to what essentially is going to be something like cybersecurity mesh architecture, a really interesting framework by Gartner, which looks at security as something which is across the entire attack surface and connected with multiple different, interconnected layers. And also Google's autonomic SOC. The other thing to note is that SIM has been claimed dead many, many times. Anton Shavakin and I, another former SIM analyst, we have this constant joke that, it's SIM dead again, simply because you always have some kind of incumbent who comes in and has a new kind of technological basis to do essentially security monitoring. UEBA was a very good example, where a lot of the UEBA vendors, user entity behavior analysis, actually thought they were going to be the next wave of SIM. Ultimately, though, what actually happens is what I call SIMification, is that as you start going further and further and into basically the market, and you meet more and more users, you have to start expanding into features and capabilities, which essentially mean you end up building a SIM. And indeed, you can see this now with some of the big XDR and EDR vendors like CrowdStrike, Palo Alto, all really running into the SIM market to try to compete there. And, I think the reason is quite simple. It's a huge market, $5 to $6 billion in the moment. And there's no end in sight of growing, because security monitoring is a constant need, more now than ever. But what has changed is just the fact that there's no single model. You'll hear people talking about a market consolidation. My own observation is that actually what we're seeing is diversification with different types of companies. If you imagine a financial institution who have a lot of personnel compared to a manufacturing company who might have a lot of different, networks, they're going to have different requirements and demands of a technology. And what we're seeing is just really the market adapting to this. Taking all of this together and into consideration, what key features do you need to evaluate today in a SIM solution? So I think if we look at just the core SIM capabilities and, the kind of things which you would think any SIM is going to be able to do, log collection and normalization. You need to ensure that the SIM can integrate with various log sources and normalize data from different environments. I think the thing to note here is that in the past, when I was speaking to buyers as an industry analyst, people would put a lot of value on a large list of connectors and integrations. I would say, look at synergies instead. Make sure that yours are covered, but look at how well they are integrated. To give you an example, you can ingest almost any log using syslog and common event format, but it's not going to necessarily give you a lot of rich data to use in further correlation analytics and dashboards. What you're really ideally looking for is that you have a good set of complementary data sources that will help you to detect any type of attack in various different stages of the actual kill chain. And so it's important to have a good understanding of how these logs and events and your log sources actually map to something like, for example, MITRE attack. Event correlation and real-time monitoring. You want to make sure that you have a lot of out-of-the-box content, because you don't want to spend the next year basically just building correlation rules and signatures. It's a never-ending task. At the same time, you don't just want to have a lot of content that basically just generates false positives. So you want well-designed, high-fidelity correlation detection content, because you need to have good coverage to be able to reliably detect an attack. But you also need to not have a lot of noisy alerts, because you will be spending a lot of your time just essentially dealing with alert fatigue. Analytics is another interesting area, because it's grown and evolved over the last years. Started out very basic. Originally, correlation was essentially a if, else, and or logic. If I see this event and I see this event and this event, flag something. Or if I see a number of different events within a short amount of time, for example, let's say a port scan or brute forcing of passwords, where you see 60 events within 30 seconds, alert somebody. Of course, nowadays we're looking at deep learning, we're looking at supervised learning and various other techniques. We'll dive a little bit deeper into that in a second as well. But it's definitely something where you need to be aware of the fact that there are different types of analytics. Automation is also becoming something that's really crucial. Famously, Gartner just a month ago or so declared standalone SOAR obsolete. I find that very predictable, because I don't think it was ever meant to be a standalone market. You would expect automation capabilities to be included in every security technology, and EDR has, I think, done a good job of showing that. But what you're looking for, even in a SIEM today, is basically intrinsic built-in automation capabilities, and not just in the form of a playbook or something which is pre-formalized. Little tweaks actually can do a lot of lifting, Scalability is also another really important topic. I had a conversation recently where somebody said to me, well, surely SIEMs were designed to scale. They weren't designed to scale. They were designed to scale from rather hundreds of alerts to tens of thousands of alerts. But nowadays we are hitting millions of alerts, potentially billions of alerts, if you look at this across a month, and some really large financial institutions, which we've heard about in the news. So scalability is actually something which is hard to test in a proof of concept if you're starting out on a low base and you don't know where you're going to be in 3 to 5 years. So this is something where it's definitely something where you want to have something which is proven, tested, and has a technological basis to be able to scale to begin with. Analytics and automation, as we mentioned, not all analytics and automation capabilities are actually created equal. For one thing, they can be applied across different stages of the detection and response lifecycle, or across different stages of the kill chain. Detection, pre-investigation, post-investigation. You can automate the investigation itself or part of the response. So be mindful of where a solution basically provides these. Essentially, you want a good, balanced, blended mix. And lastly, when you look at analytics, they've progressed and diversified. We all talk about LLMs in the moment, and Gen AI and copilots, I think, play a small role in security operations. But realistically, the tools of the trade are statistical anomaly detection. We do a lot with unsupervised machine learning, and we're starting to see a lot of work with reinforcement learning. Supervised machine learning, where you basically have labeled data, the famous example of, this is malware, this isn't malware. Actually, it's nice, it works to a degree for known knowns, but we use unsupervised machine learning and anomaly detection for the, known unknowns, where we have an idea that, okay, it might come in over HTTP, over the web, but we don't necessarily know exactly what binary it's going to be. And so one thing which I would say to evaluate here is to have explained to you, like, why are you using this? Where? How have you evaluated that this is the best method to do this? And really, there's just a couple of simple lessons, because I don't expect anyone to be a data science expert. Our job is to be security experts. But I think there are a couple of basic questions we can ask, like, how does it learn? Where is it trained, and what is it trained on? I say this because there's two really different, fundamentally different ways of learning. One is in a lab, or let's say based on sample data like malware. You have essentially a machine learning model which you feed lots of malware samples to. in the lab and you deploy it somewhere else, and it will detect the same malware samples. The second type is it will learn based off of your data. It will tailor itself to you, in which case it's really important also to know how does it unlearn, how long does it take to learn. Because a lot of these algorithms do take a lot of training data, and in the past, you want to make sure that you have sufficient of it you have sufficient of it available. But the other question is, what does it solve? Gratuitous AI is costly. If you think about using an LLM to simulate essentially what a saw does, it's going to get very, very expensive. And at the same time, there are certain things where, to be honest with you, a basic signature detection is still going to be the most cost-effective approach, especially from a computational perspective. You cannot just keep loading detections and detections on when you're essentially paying for each one of them if they don't add more value. And just using AI just to basically AI wash a solution is something that you desperately want to avoid. So what does it solve and how does it solve it? Avoid black boxes, demand explainability. You cannot go to an auditor or to your boss and say, I don't know, computer said. So make sure that there's a way to determine why a machine learning model made the decision it made. When we look at signatures, we have what's called interpretability. You can see the code, you can run the code. We don't have that with machine learning. We see the inputs, the outputs, and so we need to get a rationale for why it's making the decisions that it's making. And what are the limitations of the approach? There are no silver bullets. In security, we've been burnt in the past. We had this whole phase where basically vendors were going out and selling very basic statistical anomaly detection capabilities as the basically, be all and end all. UEBA, I think, also had a number of different offerings where it was just one algorithm which was basically reused and reused. So make sure that you also know what it doesn't detect and isn't able to do, so that you can make sure that you have a layered defense in place. And lastly, what data maturity is required. A lot of people don't realize if you're going to have good machine learning, you need to have good data to feed into it. Bad data in, bad data out. Another point to make, I think, is just the fact that, we spoke about pre-tuned detections early and high fidelity. Essentially, there's always this trade-off between recall and precision. If you imagine you can have a signature which says, alert me on PowerShell. And that's great, but what if your admins use PowerShell? So essentially, that's a very good example of something which will catch any PowerShell command, but it will catch any PowerShell command. Essentially, you want to limit that, but at that point, you might miss an attacker who's able to just deviate a little bit from that hard-coded stuff that you've defined. So we're always trying to find a balance here between precision and recall, but there's just been a recent report by Vector AI where 60% of SOC practitioners said that they feel vendors just push tools that flood the SOC with noise. And I think that's another thing to keep in mind. You only need a certain amount of detections enabled and correlation rules, and a good vendor will help you to determine these. At the same time, we can't just eliminate any kind of false positive, because ultimately we do know that attackers are evasive. They will try to bypass all of our monitoring. And so we have to have some very fuzzy or loose detections, especially when it comes to AI. And anomaly detection especially is designed to detect what a signature cannot. SIEM data models, I think, is another important point to understand in a moment. People talk about SIEM versus data lake versus XDR, but to me, they're on a spectrum. And the data lake question is very interesting because essentially today, almost every modern security technology is built on top of a data lake. The question is how much of it is exposed to the user? How much does the user have to manage? I think that a good solution is going to veer towards the power of a data lake, but also the usability of a SIEM. Yeah. If we look at what's available right now, you have this XDR with an integrated SIEM, essentially a SIEM light, because it doesn't necessarily one-to-one give feature parity like CrowdStrike. We have a traditional monolithic SIEM like IBM QRadar. Of course, SIEM with integrated data lake like Hunters. And we have even a SIEMless model or SOC-less model where people are trying to just use a whole bunch of microservices to avoid using a SIEM at all. And that's coming back to this Cambrian explosion in security and diversification. Common mistakes and pitfalls to avoid. So I think there are a number of different pitfalls which I was able to observe over the years, speaking to a lot of people buying SIEMs. I think up to 3,000 different companies I spoke to in total. And the first one is actually ignoring time to value, because, in a lot of cases, when you're deploying a SIEM, you need to deploy collectors, connectors, you need to integrate data sources. And that alone is something which I think increases a little bit the time it takes to deploy a SIEM. And of course, making this as easy as possible is something which is desirable in any modern SIEM. When you're using a lot of cloud services, you can connect to cloud API. This is fairly simple. When you're on premises and you have to actually deploy collection agents, I think it gets a lot more harder. So the important thing is that once you do have that data, you don't have to spend another couple of months actually trying to make sense of it, trying to build reports, dashboards, correlation rules, and so on, simply because it's just going to, reduce that essentially value that you're going to get out of it. And I also think it's going to mean you're exposed to risk and threat in the meantime. That's another important point to make. It's not just a business problem or an operational problem. As long as the SIEM isn't up and running, you're not as well protected as you could be. It's something which always takes longer than you expect. I have to say, having been involved with many of these projects, I think it's something where failed and flawed stored SIEM deployments have been very common in the past. They've improved over the last years. So do focus on self-service, semi-automated data source onboarding. You want a minimum initial customization of parsers, correlation rules, so that you don't have to basically go off and customize like 100 of these before you can even do anything. You want useful out-of-the-box content, well organized so that you can find it. And you do not want to need to have a lot of historical data, because a lot of people just don't. If you have to wait 4, 6, 8 weeks to train a model before it starts giving out sensible data, it's going to be basically something which is going to keep you exposed in the meantime. Underestimating resource and expertise needs is another one. SIEM is not a deploy and forget technology. Many organizations mistakenly believe that SIEM is a deploy and forget technology. It's not really like antivirus where you can just install it and you will get an alert when something happens. You need to be able to, run the architecture, maintain the architecture. You need to be able to update the content, and you need to be able to make sense of any of the alerts coming out of it. So it's really helpful to have a vendor who's going to be able to, give you help and assistance for this when you need it. You're also going to want a solution which actually includes this in the design criteria. Any kind of updates should have been vetted, carefully tested before they go out to you. They should be fine-tuned. It's not something where you get an update on Patch Tuesday and all of a sudden the next week you're basically buried by work. At the same time, though, with all of this helping, still don't underestimate the time investment. It is a solution that benefits from being used. There's a console with alerts coming in. If you spend 30, 60 minutes a day looking at what's going through, that's great. That should give you pretty good coverage. But you're going to have to spend some time on it. And if you don't fine tune it, if it's not something where the content is carefully vetted, there is a risk of burnout. There's something called alert fatigue. It's a term we've borrowed from the medical profession, where essentially you become desensitized because you keep seeing false positives. So that is something which you want to avoid as well. Something which we know has led to staff churn in SOCs as well. A good solution and a good vendor are going to help you to avoid that. Third pitfall is not understanding the true cost. People look initially at the licensing fees, but in reality, as we mentioned, you need to get the SIEM up and running. So there's professional service and consulting costs. You're also going to want to train your staff. You're going to want to have at least somebody who is on a part-time FTE actually looking at the SIEM and making sure that, nothing untoward is happening. You're going to consider ongoing tuning and maintenance, whether through you or third party. And also occasional customization costs, because you might be onboarding some kind of a new data source. You might be onboarding, maybe for a merger acquisition, actually a new business unit. Another one is getting locked in. I think it's important to note that a SIEM traditionally has not been a distributor of data. It's been a data silo. Data gets sent there and you're expected to do most of your work there, and each SIEM has an ecosystem built around it. It's great if you are invested in that ecosystem. If not, and especially because SIEM vendors have a tendency to become legacy, as we mentioned earlier, based on the database technology, it's probably a good idea to have a future-proof path to be able to move from one SIEM to another. So basically anything that overly relies on proprietary systems, anything which, has a proprietary data scheme is probably not a good idea. You should be looking at things like OCSF. You should be looking at easy ways to be able to move your data around, not just from one SIEM vendor to another, but also because security operations technology stacks are becoming more diverse. We're starting to not just run a SIEM, but maybe a SIEM plus a data lake, plus AI SecOps, plus so and so on. So you want to be able to move that data around as you need it. Avoid proprietary query languages too, because that makes it hard to move from one SIEM to another. If all of your correlation rules are basically written in a proprietary language, it makes it really painful to have to recreate them in another one. Plus there's a learning curve involved. And lastly, you want to be able to evolve and adapt your security stack. If a new detection capability comes out that your current SIEM doesn't have, you still want to have a way of being able to extend it with that. So if we go to the next section, fast tracking SIEM selection, I think there's a couple of tips that are going to help you just to expedite selecting a SIEM. Sweat saves blood. Basically, I would say be prepared, focus on features that meet your current future needs. Be clear about this. You don't need to identify a whole bunch of features that are nice to have. Right now, this is about what do you need now and what imminently over the next 18 to 24 months do you think you're going to want to add as well. Have these requirements handy. Don't get led astray by this laundry list of features and capabilities that a lot of vendors will give you that aren't relevant to you. It doesn't matter if it's not relevant to the type of threats that you're protecting against. Be clear about must-have and nice-have capabilities. Don't get sidetracked by silver bullets at all either. There are no silver bullets. You're going to have to build something together that is never going to be 100% off the shelf. I think that's my experience here. So make sure that you're clear also about the limitations of what something can provide. Run an effective proof of concept. Simulate real-world attack scenarios, even better. Mirror or replay actual production data, because if you just have a couple of scenarios basically here, it's not going to give you the full insight into how the solution works. This is, I think, the most important bit, even more important than the RFP, running an effective proof of concept that actually mirrors your production requirements. And select a vendor for long-term support. A lot of companies don't swap a SIEM every couple of years. There's a whole level of effort involved in getting it up and running, fine-tuning it to your constellation, and also learning about how to use it and learning how to make sense of the data. So it's labor intensive. It's something which you really want to avoid. Most lifetimes of a SIEM deployments, they're measured in 5 years and upwards, sometimes even 10. So make sure you have a vendor who's going to be with you for that lifetime and offer strong support services from when you start from a small scope and expand outward and grow as an organization. So conclusion QA, final thoughts, evaluate a SIEM based on flexibility, ease of deployment, automation capabilities, cost efficiency, right? All of these things matter because the total cost of ownership of a SIEM is something which I think most people underestimate generally. As we mentioned, it's not just for license cost. You have to look at this in the long term, but also all of these will matter in terms of you getting actual value out of the SIEM and getting joy out of using it. Alert fatigue, SOC burnout, all come down to not having very ergonomic SOC processes and toolings. So these things are actually hugely important. And lastly, SIEM is not one size fits all. People get carried away with some of these huge vendors or someone in the right of the quadrant, but in reality, that's a very high-end use case for large enterprises with large SOC teams. That will not work for smaller teams, and what works well in retail probably doesn't work well in manufacturing. With that, thank you very much, and questions.